All right, let's get right into it. Today, we're going to decode the secret language that's running inside every single one of your devices. Yeah, from that beast of a gaming PC to the smartphone right in your hand. We're talking about instruction sets.
I mean, have you ever really stopped to think about that? They both run apps, they both get you online, they connect you to pretty much everything, but deep down, under the hood, they're fundamentally different. And the reason for that comes down to one single core concept.
And here it is, the instruction set. Think of it as the most basic vocabulary a processor has. We're not talking about coding languages like Python or C++ here. Oh no, this is way more primitive. These are the commands that are literally hardwired into the silicon. Things like add this, move that, or compare these two things.
So, if you really want to get why our gadgets work the way they do, you've got to understand this secret language they're all speaking.
You know, in the huge world of computing, it really boils down to two dominant languages, two major players that have pretty much shaped our entire digital world for decades.
So in one corner, you've got x86. This is the absolute heavyweight champ of desktops, laptops, and servers. If you're using a Windows PC or a Mac with an Intel chip, yep, you're using x86. And in the other corner, we have ARM, the undisputed king of everything mobile. Your smartphone, your tablet, it's almost a guarantee that they're speaking ARM.
But listen, this isn't just about different company names. This is about two totally different philosophies, two different ways of thinking about how a processor should get work done. Okay, so the x86 architecture is built on this idea called CISC. And the whole point of CISC is to make the hardware, the chip itself, do as much heavy lifting as possible. They cram these incredibly powerful multi-step commands into just a single instruction. The best way to think about it is like a Swiss Army knife. It's this one tool that has a gadget for pretty much any situation you can imagine, all packed into one thing. That's CISC in a nutshell. One single command can kick off a whole chain of complicated operations inside the processor. ARM, on the other hand, takes the exact opposite approach. It follows the RISC philosophy. And what RISC does is break down every task into the absolute smallest, simplest little steps you can imagine. The entire focus is on making each tiny instruction blazingly fast to execute. So if CISC is a Swiss Army knife, think of RISC as a mechanic's specialized toolkit. You don't have one complicated tool, you have a whole set of simple tools, and each one does its one specific job perfectly and super fast. To do something complex, the processor just grabs a few of these lightning-fast tools and uses them one after the other. Let's really break this down. For x86, the CISC approach, the goal is to use fewer instructions overall. But the catch is that those instructions can be all over the place in terms of size, which demands some insanely complex circuitry on the chip. Now with ARM, the RISC way, it's all about simplicity and speed. Every single instruction is the exact same, fixed size. This makes the chip's logic way simpler and more efficient. It also means it doesn't have to reach out to the main memory as often, keeping things humming along right inside the processor's own super fast workspace. So that's all the theory, right? But what does this actually look like when a processor has to, well, do something? Let's imagine a really basic task, okay? We need to add two numbers together, and one of them is sitting out in the computer's memory. For an x86 chip, this is a one-and-done kind of job. It uses just one command, something like add, which basically tells the processor, hey, go out to this specific spot in memory, grab that number you see, and add it to the number I'm already holding on to. See? It's two actions, fetching from memory and then adding, all wrapped up in one single, powerful instruction. So, how does an ARM chip, with its RISC philosophy, handle that exact same problem? Well, it takes a much more careful, step-by-step approach. It uses a bunch of separate, simple instructions. First, there's a load instruction to go get the value from memory and bring it inside. Then, maybe a second load for the other number. After that, a super quick add instruction that only adds the two values that are now inside the processor. And finally, a store instruction to put the answer back out into memory. Yeah, it's more instructions, but each one is incredibly simple and incredibly fast. And this brings us to the most important question. Why on earth would you choose one way over the other? Well, it all comes down to this big trade-off between raw, unadulterated power and energy efficiency. That super complex circuitry in an x86 chip, it's built for one thing, brute force. It's made to just tear through massive, complicated jobs.
And that's absolutely perfect for a desktop PC or a server that's plugged into the wall 24/7. Who cares about power consumption when all you want is the absolute best performance possible?
And then there's ARM. With its simple instructions and streamlined design, it is the undisputed champion of efficiency. Each one of those little operations just sips power instead of chugging it down. And when your device is running on a battery, every little drop of energy you save means more time for you to actually use it. This is exactly why ARM is the heart and soul of the entire mobile world.
And this chart really just says it all, doesn't it? x86 pushes that performance bar as high as it can go. Meanwhile, ARM is the clear winner when it comes to sipping power. And for decades, this trade-off basically defined the entire market. You got insane performance for your desktop and incredible efficiency for your pocket.
But, and this is a big but, this is where our story gets really, really interesting. Because those clean, clearly defined lines, they're starting to get seriously blurry. I mean, think about it. What happens when you take thousands or even millions of these super efficient ARM chips and you link them all together? You get absolutely mind-blowing performance without getting a power bill that looks like a phone number. And that's exactly why ARM is now making huge moves into data centers and even supercomputing, places that used to be the exclusive playground of x86. The good old Swiss Army knife is suddenly facing off against a whole army of tiny specialized tools.
So that really leaves us with the big million-dollar question for the future of computing, right? As ARM chips get more and more powerful and x86 chips get more and more efficient, as they both start borrowing tricks from each other's playbooks, will the lines between them just disappear? Will we eventually see one single architecture that just rules everything? Now that's something to think about.